Today we're going to talk about the sine function. Earlier we've talked about finding sine and cosine values along the unit circle. And today we're actually going to graph the sine function and spend all our time with sine functions. And you know, the parent function of sine is y equals sine of theta. Okay, that's the parent function. We haven't stretched it, shrank it, added or subtracted anything to it. The sine function comes from looking at the y coordinates along our unit circle. So on the left here I've drawn a unit circle, and notice I've labeled the 5 key points: 0, pi over 2, pi, 3 pi over 2, and 2 pi. Notice in red I've marked off radians just to help us out. So the idea here is when I look at the sine function, notice how my points 0, pi over 2, pi, 3 pi over 2, and 2 pi make its way onto the x-axis. I get that from directly looking at these key points. They're the easiest ones to get nice whole number or integer values for sine. So the idea here is sine of 0 is 0, right? If we look at pi over 2, you have the order pair 0, 1. Sine is the y coordinate, so it's 1. So we have 0, 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. So we just take the y coordinates of those 5 key points, and that makes up our sine function. Now there's other ones on there, like if I did pi over 4, like halfway between, that would be root 2 over 2, which is really hard to plot. So that's why I use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Easy y coordinates. When we graph the sine function, it's always, remember, we start at a 0, max. So 0, maximum, 0, minimum, 0. Okay, and that's the 5 key points we think about. So we're going to graph a few of these, but we've got to look at some other things that affect the sine function. We're first going to talk about A and B, stretching and shrinking our sine function. A can't be 0, and B has to be greater than 0. Okay? A is called the amplitude of the function. It's half the distance between the maximum and the minimum values, and it's always positive. B is the number of cycles that the function completes on the interval from 0 to 2 pi. So basically we look from 0 to 2 pi, how many times does our function repeat? That's our B value. It's going to look a lot easier when we look at the graphs. Two more definitions. What is the period? A period is a length, okay? It's the horizontal length of each cycle. So if you tell me, hey, this is a cycle, and I say, well, what's the length of the cycle? That's the period. It's found by taking 2 pi dividing by b. 2 pi divided by the number of cycles. And again, the cycle is the shortest repeating portion of the graph. And so let's look at an example where we have to find the period and the cycle visually, so this can help us understand period and cycles. Now, my graph looks at 2 pi, 3 pi over 2, pi, and pi over 2, and 0. The 5 key points off the unit circle. So the blue graph here is the standard y equals sine of x. In this case, they're asking us to determine the number of cycles and the period. Now, I drew each cycle in a different color so you could see. So I start at 0, and I go up on my red function, and notice how I stop at pi over 2 and I repeat. Then I start again, that same graph, the cycle. Then I go to the orange graph. It stops at 3 pi, and then it's from 3 pi to 2 pi is another one. So I see 4 cycles from 0 to 2 pi, 4 different colors. This graph repeats. 1, there's the first one, there's 2, there's 3, and there's 4. Okay? B is equal to 4. There's 4 cycles from 0 to 2 pi. So if B is 4, that means the period is 2 pi divided by 4, or pi over 2. So that's the length of the period. So this red cycle is from 0 to pi over 2, it repeats. That's the distance. So that's our period. So that's how we look at period and our cycles. And we're going to use that throughout the rest of this video. So we only have two graphs here, but I wanted to show you the importance when a was equal to 3 and when b is equal to 3, how different these graphs look. Now, if I look at graphing y equals 3 sine of x, my b value is 1. So to find the period, I take 2 pi divided by b, or 2 pi divided by 1, which is 2 pi. So let's draw the axes. I mark the axes, and I go out some distance, I mark it off as 2 pi. I like to go in half, so half the distance, there's pi. And from here to here, half the distance is pi over 2. And from pi to 2 pi, half the distance is 3 pi over 2. So think about it. Pi over 2, like 1 half, 1, 3 halves, 2 pi. So I've got my 5 key points. 0, pi over 2 pi, 3 pi over 2, and 2 pi. Now, a is 3. So that means that right now the max and min is going to be 3 because I'm not adding anything to this function. And it'll change later when we start translating. But when a is 3, we stretch our max up to 3 and our minimum down to 3. So with the sine function, we start at 0, max, 0, min, 0. So notice in blue, that's the original sine graph from 0 to 2 pi. Now here's our new graph in red. That's one cycle. It's got one cycle, b is 1, from 0 to 2 pi. It doesn't repeat. So you can see all we've done is really just stretch that graph out. The harder graph to do is when you have your b value. Okay, b value other than 1. In this case, y equals sine of 3x. So b is 3. So that tells me from 0 to 2 pi, I'm going to have 3 graphs that look the same, 3 pieces. It's going to repeat 3 times. The b value is 3. That means my period is 2 pi over 3. Okay, so if you think of 2 pi being, the normal graph, one cycle, this thing repeats 2 pi over 3. So before we even get halfway around the unit circle, this function is going to start repeating again. So let's draw it. In blue, I've drawn the sine function. Now, I drew out to pi, okay, and then I went to halfway between is pi over 2, okay, and then I drew 2 pi over 3 here. I did a little estimation, okay, it's 2/3, okay, so 2/3, and from 0, half of 2/3 is 1/3, half of a third is a sixth, so it's 1/6, 2/6, pi over 3, 3/6, pi over 2, 4/6, which is 2 pi over 3, and you can keep going. So here's my interval. Again, how do you find that interval? I look at my period and I put 2 pi, I mark 2 pi off somewhere. Halfway between is pi over 3. Half from 0 to pi over 3 is pi over 6. Remember, I talked about making these x coordinates here, radians, in halves. It's the easiest way to do it. Our a value is 1, so the height and the max and min are not going to change. In blue is the standard sine function. So here's 0, pi over 2 is 1, pi is 0. So there's part of the graph. Now our red graph is y equals sine of 3x. 0, so 0 max, 0 min max. Our max is 1, our min is -1, so there's our function. And you can see there's one graph, and then it would repeat, and then it would repeat all the way to 2 pi. So you can see how much quicker this graph repeats, and we've only gotten to here. So if you're looking at what's equivalent, the blue graph represents this little portion right here, this first hump right here. So you can see how much quicker the red graph is. So when you make b a large number, the graph cycles much faster. Okay? So that's graphing basic sine functions. Y equals a sine of bx. We're going to get into translating horizontally and vertically later on. But if you have any questions, you can type them below, or you can email me at nicholas.bennett@dc.gov. Thanks.